It's a stellar explosion so bizarre, so unprecedented, that one astronomer said it looks like nothing anyone has ever seen before. We're talking about a brand new type of supernova that flipping the script on how we thought massive stars end their lives. So buckle up, because we're about to witness a star that was stripped down to the bone before putting on its final, spectacular light show. First, let's do a quick refresher on how stars, especially the really big ones, work. Imagine a massive star, one that's 10 to 100 times heavier than our sun, as a kind of celestial onion. The outermost layers are the lightest elements, mostly hydrogen and helium. Deeper inside, you find progressively heavier elements. This is all powered by nuclear fusion in the star's core, where insane temperatures and pressures fuse lighter elements into heavier ones. It starts by turning hydrogen into helium, then helium into carbon, and so on, building up layers of oxygen, silicon, and more. This process releases a tremendous amount of energy, creating an outward pressure that fights against the star's own immense gravity, keeping it from collapsing. The end of the line for a massive star comes when it starts to create iron in its core. Fusing iron doesn't release energy, it actually consumes it. With the energy production shut off, gravity wins the tug of war. The core collapses catastrophically, triggering a mind-bogglingly powerful explosion we call a supernova. This explosion blasts the star's outer layers across the galaxy, seeding space with the heavy elements necessary for planets and even life. That's the textbook model we've understood for decades, but then along came supernova SN 2021YFJ, and it decided to tear up the textbook. In September 2021, astronomers using the Zwicky Transient Facility in California spotted an object 2.2 billion light-years away that was rapidly getting brighter. They knew they had a supernova, but they had no idea just how strange it was. When a star goes supernova, we expect to see the fingerprints of its outer layers, the hydrogen, the helium, in the light from the explosion. But with SN 2020YFJ, those layers were just gone. It seems that long before it exploded, the star had somehow shed its outer coat of hydrogen, helium, and even carbon. What was left was something we have never seen exposed like this before: the deeper layers of silicon, sulfur, and argon. It's like the star performed a cosmic striptease, shedding its outer layers until only its inner structure was left. Then when the core finally collapsed and the supernova blast wave ripped outwards, it slammed into this nearby shell of freshly ejected material. The collision was so energetic that it lit up this silicon and sulfur shell, making it glow intensely. For the first time, astronomers got a direct look at a layer that's normally hidden deep inside a star right before it dies. Steve Schulze, the lead author of the study, put it perfectly. This is the first time we have seen a star that was essentially stripped to the bone. It proved that stars can lose an incredible amount of material, right down to their deepest layers, and still go out with a brilliant bang. This discovery is huge because it gives us direct evidence for the layered onion structure of massive stars that we've only theorized about. But it also raises a ton of new questions. How did this star lose so much of its mass? The team estimates it must have shed material equivalent to 3 times the mass of our sun over its lifetime. That's an extreme amount of mass loss. One leading idea is that the star was incredibly unstable in its final years. Stars can experience violent instabilities that cause them to pulsate, contracting, and then suddenly liberating so much energy that they blow off their outermost layers not once, but multiple times. Another possibility is that it had a companion star that siphoned off its outer material like a cosmic thief. Or maybe it was a series of massive pre-supernova outbursts. The researchers are leaning towards the idea that the star literally tore itself apart. Whatever the cause, it created a scenario that has completely redefined our understanding of stellar evolution. The team has officially designated this a new class of supernova, a type ion. Supernova classifications are based on the elements we see in their light. Type 2s have hydrogen, type Ibs have helium but no hydrogen, and type X have neither. Each type reveals a progressively deeper layer of the original star. Since this new supernova showed us elements like silicon and sulfur, which are formed in the deepest, innermost layers, it needed its own category. The N in ion stands for narrow, referring to the narrow emission lines in its spectrum caused by the blast wave interacting with that nearby shell of gas. This spectrum was the key to the whole discovery, and what a discovery it was. It almost didn't happen. Initially, the team just saw a bright dot getting brighter. They needed a spectrum, a breakdown of the light into its different colors, to understand what elements were present. Luckily, another astronomer, Yi Yang, happened to capture a spectrum with the powerful Keck Observatory in Hawaii. Without that crucial piece of data, we might have just catalogued it as another supernova and missed its extraordinary nature entirely. When experts saw the spectrum, they were stumped at first, until they realized they were looking at the spectral signatures of silicon and sulfur, something never seen in this context. This raises a fascinating and slightly unsettling question. How many other strange cosmic events like this have we missed? The astronomer Adam Miller wondered, did we happen to just get incredibly lucky? Or are there a lot of these out there and we haven't been searching in the correct way to find more? New observatories are going to discover millions of supernovas, but most won't get that detailed spectral follow-up. We might need smarter ways, maybe using AI, to flag the truly weird ones for a closer look. SN 2020 YFJ has shown us that the zoo of astronomical transients is still not complete, as one expert put it. Our universe is filled with exotic pathways for stars to live and die, and we've just been given a tantalizing glimpse into one we never knew existed. It's a beautiful reminder that no matter how much we learn about the cosmos, it always has another surprise waiting for us, challenging our theories and expanding our sense of wonder. What do you think caused this star to shed its layers? A binary companion? Violent stellar winds? Let me know your theories in the comments below. Hey everyone, and welcome back to the channel. Get ready for some absolutely incredible news from space. A powerful solar storm, a real behemoth, is hurtling towards Earth right now, and it's set to arrive this evening. What does that mean for you? It means we could be in for one of the most spectacular displays of the northern lights, or aurora borealis, seen in years. The really exciting part is where these lights might be visible. We're not just talking about the usual spots up near the Arctic Circle. According to the U.S. National Oceanic and Atmospheric Administration, or NOAA, this celestial light show could dip much farther south than usual. We're talking about states in the lower Midwest and even as far as Oregon. Imagine looking up from your backyard in Iowa or Illinois and seeing the sky shimmering with green and purple light. It's a truly rare opportunity. Now let's get into the science of it all. Scientists have a rating system for these solar storms, kind of like how we rate hurricanes. It's a G scale from G1, minor, to G5, severe. The forecast for tonight starts at a moderate G2 or G3 level. But here's where it gets even more interesting. Forecasters at the UK's Met Office believe the storm could ramp up to a rare G4 designation as we head into the early hours of Tuesday morning. A G4 storm is considered severe and has the potential to create some truly breathtaking auroral displays. To put that into perspective, a map of the storm's potential view line shows that these dazzling lights could stretch all the way down to Upper Oregon, Idaho, Wyoming, Nebraska, Iowa, Illinois, and even upstate New York and northern New England. So if you're in any of those areas, you'll definitely want to keep an eye on the sky tonight. Over in the UK, the Met Office is saying the auroras might be visible across much of the country, possibly even without special camera equipment, as long as the skies are clear. There is one small catch though. A bright waxing gibbous moon might wash out the view a little bit. But let's keep our fingers crossed that the aurora will be strong enough to shine through. So, what's causing this incredible event? It all started on Saturday with something called a coronal mass ejection, or CME. Picture this. The sun's outer atmosphere, the corona, suddenly erupts, blasting a massive cloud of superheated gas called plasma and magnetic fields out into space. And this wasn't a small burp. This material is traveling at a mind-boggling speed, estimated by NOAA to be around 2 million miles per hour. That's fast enough to get from the sun to Earth in just a couple of days. This massive wave of solar particles is expected to make its grand entrance at Earth this evening, with the peak activity happening between 2 a.m. and 5 a.m. Eastern Time on Tuesday. When these high-energy particles from the CME finally reach our planet, they don't just stop. They slam into the atoms and molecules in our upper atmosphere. This collision is like striking a cosmic bell. It energizes the atmospheric gases, causing them to glow. The different colors we see in the aurora depend on which gas is being hit. When solar particles hit oxygen, we get that beautiful, classic green glow. When they interact with nitrogen, we can see stunning shades of blue and purple. It's literally a collision of worlds creating a masterpiece in the sky. Now, if you're thinking, this seems to be happening more often lately, you're not wrong. The sun is currently in a phase of its 11-year cycle called the solar maximum. This is the peak of its activity, meaning we can expect more sunspots, more solar flares, and yes, more of these powerful CMEs that lead to gorgeous auroras. We've already seen several notable geomagnetic storms over the past year, including that incredible one back in May 2024 and another strong one last October. So this is all part of a larger, very active period for our star. It's important to keep expectations in check though. According to Sean Dahl, a space weather forecaster at NOAA, even though this CME is aimed directly at Earth, it's not guaranteed to be as powerful as some of the storms we've seen recently. He mentioned that while the UK's Met Office issued a G4 watch, NOAA is a bit more cautious. They think there's a chance for a G4 storm, but it all depends on the strength and orientation of the CME's magnetic field. We want to know for sure until it reaches a special satellite observatory located about 1 million miles from Earth. This gives us a little bit of a heads up. The Space Weather Prediction Center estimates that the CME will hit that 1 million mile mark about 20 to 50 minutes before it arrives here on Earth, sometime late this afternoon, Eastern Time. So forecasters will be watching that data very, very closely to give us a more precise idea of what to expect. This is real-time space science in action, and it's happening right now. Of course, with great power comes, well, potential for some minor disruptions. While a G4 storm can produce amazing auroras, it can also affect our technology. We're talking about possible GPS satellite disruptions, interference with radio signals, and minor fluctuations in power grids. It's a reminder of just how connected we are to the sun's activity. However, for this specific storm, NOAA has stated that they expect only limited minor effects on our technological infrastructure and that these are usually manageable, so there's no need to worry. The main event here is the incredible light show. So what's the plan? If you live in one of the areas I mentioned and you have clear skies tonight, get away from city lights if you can. Find a dark spot with a good view of the northern horizon. The peak is expected in the very early morning hours, but the show could start earlier in the evening. Be patient, let your eyes adjust to the darkness, and look north. You might just witness one of nature's most magical displays. This is a fantastic opportunity for photographers, stargazers, or anyone who just wants to see something truly awe-inspiring. This is a developing story, and we'll be keeping an eye on the latest updates from NOAA and other space weather agencies. Let us know in the comments below if you're planning on heading out to look for the aurora tonight. We'd love to hear where you're watching from, and if you manage to capture any photos, we'd be thrilled to see them. Thanks so much for tuning in. Stay safe, look up, and I hope you get to see the show. Could we be on the verge of discovering a second Earth? What if I told you that just 40 light years away, astronomers might be about to confirm an Earth-like atmosphere on another planet? This isn't science fiction anymore. Thanks to the incredible James Webb Space Telescope, we're peering into distant worlds like never before, and what we're finding is absolutely mind-blowing. Welcome back, everyone. Today, we're diving deep into one of the most exciting planetary systems ever discovered, TRAPPIST-1. Picture this, a tiny, cool star about the size of Jupiter with not one, not two, but 7 rocky planets orbiting it. It's a system so compact that all 7 planets would fit neatly inside the orbit of Mercury in our own solar system. And the best part? 3 of these planets are in the habitable zone, that sweet spot where temperatures could be just right for liquid water to exist on the surface. This system, TRAPPIST-1, was discovered back in 2016 and, fun fact, was named after the discoverer's favorite Belgian beer. Ever since, it's been a prime target for astronomers, and now, with the power of the James Webb Telescope, we're getting our closest look yet. The focus of all this excitement is a planet called TRAPPIST-1e. It's the 4th planet from its star, and it's remarkably similar to Earth in size. So how do we even begin to look for an atmosphere on a planet 40 light years away? It's a clever technique. Astronomers wait for the planet to pass, or transit, in front of its star. As the starlight filters through the very edge of the planet, they can analyze it for tiny changes. If there's an atmosphere, certain wavelengths of light will be absorbed by the gases within it, leaving a chemical fingerprint that the Webb telescope can detect. It's like cosmic detective work on an interstellar scale. Recently, a team of astronomers, including Nestor Espinosa from the Space Telescope Science Institute, conducted 4 observations of TRAPPIST-1e as it transited its star. And the results? Well, they're tantalizing. The telescope was unable to rule out the presence of an atmosphere. As Espinosa put it, the dream is still alive. This is huge because for other planets in the system, like the innermost one, TRAPPIST-1b, Webb has already confirmed they have no significant atmosphere. But for TRAPPIST-1e, the possibility remains wide open. What's even more interesting is what they did manage to rule out. The data suggests that TRAPPIST-1e doesn't have a thick, hydrogen-based atmosphere like a gas giant. It also probably doesn't have a dense, carbon dioxide-rich atmosphere like Venus or Mars. This process of elimination points towards a fascinating possibility, a nitrogen-heavy atmosphere, much more similar to our own Earth or Saturn's moon, Titan. Think about that for a second. We're not just looking for any atmosphere. We're starting to narrow it down to the kind that could support a world like ours. Of course, the star in the TRAPPIST-1 system is a red dwarf, which is very different from our Sun. These stars are known to blast their nearby planets with intense radiation, which could strip away any atmosphere. In fact, it's likely that TRAPPIST-1e lost its original primordial atmosphere long ago, just like Earth did. The big question is whether it managed to form a secondary atmosphere, like Earth did, through volcanic activity and other geological processes. Finding an atmosphere around TRAPPIST-1e would be groundbreaking because it would prove that planets orbiting the most common type of star in the universe, red dwarfs, can indeed hold on to their atmospheres. This would multiply the potential number of habitable worlds out there exponentially. Now, it's important to keep our excitement grounded in the science. These initial 4 observations are just the beginning. The results are, as one astronomer put it, interesting but also incomplete. Michael Gillon, who led the original discovery of the TRAPPIST-1 system, said that while the data isn't conclusive yet, it proves that for the first time in history, we are truly within reach of detecting an Earth-like atmosphere on a potentially habitable exoplanet. The team is already in the middle of a much larger follow-up program, with 15 more observations planned for this year. By the end of this year, we could have a much clearer picture. Computer simulations add another layer of intrigue. Some models suggest TRAPPIST-1e is at a tipping point. It could have formed as a dry, barren desert world, or it could have formed as a wet, ocean-covered planet. The current data can't distinguish between these two scenarios, but that's exactly what the simulations predicted. It means the next set of observations could deliver a dramatic reveal one way or the other. We are literally on the edge of our seats, waiting to see which way the evidence will fall. If the next round of observations confirms an atmosphere, the next step would be even more exciting. Scientists could then use the Webb telescope to search for specific biosignatures, gases like methane, which on Earth is strongly associated with life. The confirmation of an atmosphere alone would be one of the biggest astronomical discoveries of our time. But finding biosignatures, that would change everything we know about our place in the universe. But what if they find nothing? What if TRAPPIST-1e turns out to be another bare rock in space? Well, even that would be a profound discovery. It would highlight just how special and rare our own planet is. It would tell us that perhaps the conditions that allowed life to flourish here are even more unique than we imagined. Either way, we win. We gain a deeper understanding of the cosmos and our place within it. Think about how far we've come. Just a few years ago, studies like this were pure science fiction. Now, we have a telescope in space, powerful enough to sniff out the air of a world trillions of miles away. We are living in an unprecedented era of discovery. The story of TRAPPIST-1e is still being written, and we get to watch it unfold in real time. Will it be a second Earth, a water world, or a desolate rock? We may know the answer very, very soon. Hey everyone, and welcome back to the channel. If you're a fan of looking up at the night sky, you are in for a serious treat. This weekend is packed with not one, but 2 incredible celestial events. So grab your calendars and let's dive into what's happening above us. First up, on Sunday, we have a partial solar eclipse. This happens when the moon passes between the sun and Earth, but doesn't completely cover the sun. Instead, it looks like the moon is taking a little bite out of our star. The whole event kicks off around 1:29 p.m. Eastern Time and will wrap up by 5:53 p.m. The peak moment, when the moon blocks the most of the sun, will be at 3:41 p.m. ET. Now, before you get too excited, I have to break some news. For those of us in the United States and most of the Northern Hemisphere, this one isn't for us. According to NASA's Jason Rhodes, this particular eclipse will be best viewed from the South Pacific, New Zealand, Antarctica, and parts of Australia. So if you're in that part of the world, congratulations. So why do eclipses happen? It's all thanks to a beautiful cosmic coincidence. As Rhodes explains, even though the sun is way bigger than the moon, it's also much, much farther away. From our perspective here on Earth, they appear to be almost the exact same size in the sky. This allows the moon to perfectly align and block the sun, giving us these spectacular eclipses. Now, for those lucky enough to see it, let's talk about safety. This is incredibly important. You should never ever look directly at a solar eclipse without proper eye protection. Even during a partial eclipse, the visible part of the sun is powerful enough to cause severe and permanent eye damage. Your regular sunglasses are not safe for this. I repeat, they are not safe. You need to use certified eclipse glasses or a handheld solar viewer. These are specially designed and are about 100,000 times darker than sunglasses. Look for the ISO 12312 International Standard label to make sure they're legit. When you use them, put them on before you look up at the sun and turn away from the sun before you take them off. And if you have kids with you, please keep a close eye on them to make sure they're using the glasses correctly and not peeking. If you're an astrophotographer or have a telescope or binoculars, you can also use a special solar filter that fits on the front of your lens. But please do not look through an unfiltered camera, telescope or binoculars, even if you're wearing eclipse glasses. The focused light can burn right through the filter on your glasses and cause serious harm. Safety first, always. Okay, so what about the rest of us who will miss the eclipse? Don't worry, the cosmos has something for us too. Also on Sunday around 2 a.m. Eastern Time, the planet Saturn will be at opposition. This is a fantastic opportunity for skygazers in the Northern Hemisphere. What does opposition mean? It's when a planet is on the opposite side of Earth from the Sun. Imagine a straight line with the Sun at one end, Earth in the middle, and Saturn at the other end. For planets farther from the Sun than us, like Saturn, opposition is the absolute best time to see them. It's when they are at their closest to Earth and appear at their brightest and largest in our sky. And the best part, you can easily spot Saturn with just your naked eye. It will look like a very bright, steady star. Saturn will actually be visible for a while, right through early October, so you have plenty of chances to find it. But this weekend is special. We're also entering a phase where the moon won't be as bright, which means less light pollution in the sky, making this year's Saturn opposition particularly good for viewing. If you really want a mind-blowing experience, I highly recommend finding a local astronomy club or a friend with a telescope. While Saturn looks like a bright star to the naked eye, a telescope reveals its magnificent rings. Seeing those famous rings for yourself is a moment you will never forget. It's truly one of the most stunning sights in our solar system, but the celestial fun doesn't stop this weekend. The rest of the year is filled with amazing events to look forward to. Let's talk about full moons. We have 3 more to go in 2025. And get this, they are all supermoons. A supermoon happens when a full moon coincides with its closest approach to Earth, making it appear slightly larger and brighter than usual. Mark your calendars. On October 6th, we have the harvest moon. Then on November 5th, it's the beaver moon. And we'll close out the year with the cold moon on December 4th. 3 supermoons in a row is a fantastic way to end the year. And of course, we can't forget about meteor showers. These are perfect for grabbing a blanket, lying back, and watching shooting stars streak across the sky. Coming up, we have the Draconids peaking on October 8th and 9th, followed by the Orionids on October 22nd and 23rd. In November, we get a double feature with the Southern Taurids on November 3rd and 4th, and the Northern Taurids on November 8th and 9th. The famous Leonids will peak on November 16th and 17th. Then, December brings one of the best showers of the year, the Geminids, on December 13th and 14th, and finally, the Ursids will close out the meteor shower season on December 21st and 22nd. That's a lot of wishes to be made. So, whether you're in the Southern Hemisphere preparing for a partial solar eclipse, or in the Northern Hemisphere getting ready to spot Saturn, this weekend is a reminder of the incredible universe we live in. I encourage you to take a moment, step outside, and look up. You never know what wonders you might see. That's all for today. I hope this gets you excited for the weekend's celestial shows. Ever looked at your watch and thought, what time is it on the moon? Probably not, but for NASA and space agencies around the world, this is becoming a very real and very tricky question. The answer isn't as simple as just adding a new time zone. We're talking about creating an entirely new way to measure time itself. So, why the sudden rush to figure out lunar time? It all comes down to one of the weirdest, most mind-bending quirks of our universe, thanks to a guy named Albert Einstein. His theory of general relativity tells us that gravity actually slows down time. The stronger the gravity, the slower time ticks. You might not notice it, but seconds tick by ever so slightly faster on a mountaintop than they do down in a valley. On Earth, these differences are so tiny they don't matter for our day-to-day lives. But when you go to the moon, where gravity is much weaker, those tiny differences add up. On the lunar surface, a clock would tick about 56 microseconds faster every single day compared to a clock on Earth. Now, 56 microseconds sounds like nothing, right? It's a fraction of a blink of an eye, but in the world of space exploration, where precision is everything, those microseconds can lead to massive problems. Think about it. We're entering a new space race. The US, China, and their allies are all planning to build permanent bases on the moon. Astronauts will need to navigate, communicate, and synchronize their operations with missions back on Earth. If their clocks are out of sync, even by a tiny amount, it could throw off everything. Imagine trying to land a spacecraft or have two moon buggies meet up. When your navigation systems are running on slightly different times, it could be disastrous. That's why the White House has officially tasked NASA with creating a new standardized timescale for the moon called Coordinated Lunar Time, or LTC. The goal is to have a plan by the end of this year and implement the system by 2026, which is right around when NASA's Artemis mission aims to land astronauts back on the lunar surface. So, how did we even end up with this time problem? Let's take a quick trip back. For thousands of years, humanity told time using the sun and the moon. Sundials, stone circles, they did the job. Then, in the 14th century, mechanical clocks appeared, and the obsession with precision began. But our modern understanding of time was completely shaken up by Einstein. Let's try a simple analogy. Imagine space and time are a giant sheet of fabric. Now, place heavy objects on it, like the sun and the planets. The heavier the object, the deeper the dent it makes in the fabric. That dent is gravity warping space-time. Because the Earth is much more massive than the moon, it creates a much deeper gravity well, causing time to pass more slowly here. On Earth, we've found a clever way to handle this. We have hundreds of ultra-precise atomic clocks scattered across the globe. These clocks use the vibration of atoms to measure time. By averaging out the readings from all these clocks, we get our global standard. Coordinated Universal Time, or UTC. It's what keeps our entire modern world quasi-synchronized, from the stock market to your GPS. Everything relies on this precise timing. Now, we need to do the same thing for the moon, but it's not as simple as just using Earth time. Astronauts on the International Space Station, for example, are in a unique spot. They're in weaker gravity, so time should speed up for them. But they're also traveling at 17,500 miles per hour. And according to Einstein's other big theory, special relativity, the faster you move, the slower time passes. For the ISS, these two effects, Akarshan, cancel each other out, so they can just use Earth time. The moon is different. It's far enough away and moving in such a way that the gravitational effect protects them. Time genuinely runs faster there. So, what's the plan? NASA and other international partners are developing something called LunarNet. You can think of it as the moon's version of the internet and GPS combined. It will provide navigation and communication services for all lunar missions. But for LunarNet to work, it needs a rock-solid, agreed-upon timekeeping system at its core. This means we literally have to send clocks to the moon. But what kind of clocks and where do we put them? Scientists are discussing placing a network of clocks, likely a mix of super-stable atomic clocks and more affordable crystal oscillators, both in orbit around the Moon and on its surface. As Cheryl Gramling, a lead scientist at NASA, says, "You never trust one clock, and you never trust two clocks. You need a whole network to ensure accuracy. An atomic clock, e.g. for space travel, can cost a few $1,000,000, but the precision is worth it. For navigation, you need clocks synchronized down to the nanosecond. That's a billionth of a second. A tiny error in time can translate to a huge error in location." Interestingly, the plan isn't to slow down the lunar clocks to match Earth's. The goal is to let them run at their natural lunar pace and create a new independent time scale. Then we'll build a mathematical model to precisely translate between Moon time and Earth time. This will be a huge challenge, not just technically but diplomatically. Getting all spacefaring nations, including rivals like China, to agree on a single standard for time will require a lot of international cooperation. But it's not just about the clocks. Think about the astronauts who will live there. An Earth day is 24 hours. A lunar day, from one sunrise to the next, is about 29.5 Earth days long. That means roughly 14 days of constant, blinding sunlight, followed by 14 days of frigid, absolute darkness. How do you establish a work-sleep schedule in that environment, especially at the lunar South Pole, where there are areas of permanent light and permanent shadow right next to each other? It's a completely different mindset. Whatever time their watches show, life on the Moon will be unlike anything we've experienced. But getting the timekeeping right is the foundational step. It's the invisible infrastructure that will make everything else possible, from scientific exploration to building a sustainable human presence. And this is just the beginning. By figuring out how to create a timekeeping system for the Moon, we're essentially creating a blueprint. As NASA's Kevin Coggins puts it, we're learning what we can, so we are prepared to do the same thing on Mars or other celestial bodies in the future. We're not just setting clocks, we're setting the stage for humanity's future in the cosmos. Today, we're diving deep into a story that sounds like it's straight out of science fiction. Astronomers have found a rogue planet, a world wandering through space without a star, that's behaving in a way they've never seen before. It's having a massive growth spurt, and the numbers are absolutely mind-boggling. Imagine a planet 5 to 10 times more massive than Jupiter, just floating out there in the cosmos. This isn't just any old planet, though. This is CHA 1107-7626, a cosmic infant, only about 1 or 2 million years old. For comparison, our own solar system is a mature 4.5 billion years old. So this planet is still in its nursery, and it is growing up fast. Located 620 light-years away in the Shamalian constellation, CHA 1107-7626 is surrounded by a massive disk of gas and dust. Think of it like a giant cosmic buffet, and this planet has a ferocious appetite. Using the combined power of the Very Large Telescope in Chile and the James Webb Space Telescope, scientists watched in awe as this planet went on an unprecedented feeding frenzy. Over just a few months, its growth rate skyrocketed. It started gobbling up gas and dust at a record-breaking rate of 6.6 billion tons per second. Let that sink in. 6.6 billion tons of material every single second. That's like consuming the mass of Mount Everest multiple times a minute. This is the strongest growth rate ever recorded for any kind of planet, and it is giving us a rare glimpse into the wild and chaotic childhood of these mysterious objects. Astronomers were stunned. One of the study's authors, Alex Schultz, said he expected a short-term event, but when the burst just kept going for months, he was absolutely stunned. It's like they caught this newborn planet red-handed, in the act of a furious feast. This turbulent behavior is completely changing what we thought we knew about the early lives of planets. So how does a planet put on so much weight so quickly? The evidence points to something we usually associate with stars, powerful magnetic fields. It seems that this planet, despite being less than 1% the mass of our Sun, has a magnetic field strong enough to pull in enormous amounts of material from its surrounding disk. This discovery blurs the lines between how planets and stars form. In fact, that's one of the biggest questions surrounding rogue planets. Are they just planets that got kicked out of their original solar systems, or are they something else entirely? For CHAR 11077626, scientists believe it's the latter. They think it formed, just like a star does, from the collapse of a giant cold cloud of gas and dust. It's essentially a failed star, or what we sometimes call a brown dwarf, but it's acting in ways that make it look a lot like a baby star. Senior co-author Ray Jayawardena put it perfectly. We are struck by quite how much the infancy of free-floating planetary mass objects resembles that of stars like the Sun. This similarity suggests that some objects as big as giant planets might not be planets in the traditional sense at all, but rather the smallest possible outcome of star formation. What's even more fascinating is the chemical changes the James Webb Telescope detected. During this massive growth spurt, water vapor suddenly appeared in the planet's disk where it wasn't before. This is the first time we've ever seen the chemistry of a disk change around a planet, not a star. It's a testament to the incredible power of Webb to see these faint details from so far away. This isn't a one-time thing either. Looking back at old data, the team found evidence that this planet had another growth spurt back in 2016. This suggests these events might be recurring. The big questions now are, how long do these bursts last, and how often do they happen? Answering that will tell us how much these furious feasts actually contribute to the planet's final size. The implications are huge. As Dr. Jacco van Loon, an astrophysicist not involved in the study, pointed out, if this planet is forming in a disk of material, what about any moons that might be forming in that same disk? He imagined something like Saturn's moon Titan, which has its own atmosphere and weather. Could a moon orbiting this giant rogue planet one day host life? It's a tantalizing thought that pushes the boundaries of where we might look for life in the universe. Of course, finding and studying these dim, wandering worlds is incredibly difficult. They're like cosmic needles in a haystack, but a new generation of telescopes is on the horizon. The Vera Rubin Observatory, the extremely large telescope, and the Nancy Grace Roman Space Telescope are all set to revolutionize our search for these objects. They'll be able to spot these rare growth spurts across the galaxy, giving us a statistical picture of how these mysterious worlds are born and evolve. We are truly living in a golden age of astronomy, where every new observation seems to reveal a universe that is more dynamic, more chaotic, and more wonderful than we ever imagined. The story of CHAR 11077626 is a perfect example, showing us that even in the darkest corners of space, the processes of creation are furiously at work. What do you think about this ravenous rogue planet? Does it change how you think about our place in the cosmos? Let me know your thoughts down in the comments. Imagine listening to the universe's most ancient secrets. Well, astronomers just did exactly that. And what they heard confirms theories from two of the greatest minds in history, Albert Einstein and Stephen Hawking. Just recently, scientists detected the collision of two massive black holes, an event they've named GW5014. This wasn't just any cosmic fender bender. It was a cataclysmic merger that sent ripples through the very fabric of space and time. These ripples, called gravitational waves, traveled for 1 billion years before reaching us here on Earth. And for the first time, we had the technology to not just detect them, but to see the event in stunning, unprecedented detail. This incredible feat was achieved by LIGO, the Laser Interferometer Gravitational Wave Observatory. Think of it as a giant cosmic ear, listening for the faintest whispers from the universe. Gravitational waves were first predicted by Einstein back in 1915 as part of his theory of general relativity. He actually thought they'd be too weak for us to ever detect. But in 2015, LIGO did the impossible, picking up its first signal from a black hole merger and earning its creators a Nobel Prize. Now, fast forward to today. The instruments have been upgraded, becoming more sensitive than ever. The two black holes in this latest event were giants, each about 30 to 35 times the mass of our Sun. They were spinning slowly, orbiting each other in a near-perfect circle before their final dramatic collision. The resulting single black hole is a behemoth, about 63 times the mass of the Sun, and it's spinning at an incredible 100 revolutions per second. What makes this so special? Professor Maximiliano Isi, who led the new study, says that because the instruments are so much better now, we can see the merger with much greater clarity. It's like going from a blurry, out-of-focus picture to a crystal-clear 4K image. This new view is giving us a completely fresh perspective on the dynamics of space and time itself. So how does LIGO even work? It's a collaboration of about 1,600 researchers worldwide, with detectors in the US, Italy, and Japan. These instruments are so precise, they can detect a change in distance 1,000 times smaller than the nucleus of an atom. It's like measuring the distance to the nearest star, with an accuracy smaller than the width of a human hair. Thanks to this precision, we've now observed over 300 black hole mergers. This latest observation, GBD 25014, was so clear that it allowed scientists to put two major, decades-old predictions to the test. The first comes from an idea that builds on Einstein's work. Back in 1963, a mathematician named Roy Kerr proposed that black holes, despite their mysterious nature, are actually incredibly simple. He suggested that everything you need to know about a black hole can be described by just two numbers: its mass, or how big it is, and its spin, or how fast it's rotating. That's it. All their complexity boiled down to two simple properties. To test this, scientists listened for something truly amazing: the ringing of the new black hole. Just like a bell rings when you strike it, a newly formed black hole vibrates, sending out gravitational waves. Professor Isi explains that the pitch and duration of this ringing tell you about the black hole's structure. Before, we'd only heard a faint hum. But with GW 250140, the signal was so strong they could hear multiple tones, a fundamental mode and an overtone. It was like hearing a musical chord instead of just a single note. By analyzing these two distinct tones, the team confirmed that the new black hole's properties perfectly matched the predictions based on just its mass and spin. This is the most compelling evidence we have that black holes are these elegantly simple, featureless objects, just as the theory predicted. It's a fundamental confirmation of how space and time operate at their most extreme. But that's not all. The second major confirmation comes from the legendary Stephen Hawking. In 1971, Hawking proposed a simple but profound rule known as the black hole area theorem. It states that the surface area of a black hole can never decrease. When two black holes merge, the surface area of the final combined black hole must be equal to or greater than the sum of the two original areas. Again, the clarity of the GW 50142 signal was key. For the first time, researchers could accurately measure the surface areas of the two individual black holes before they merged. Then they looked at the final signal from the new single black hole and measured its area. The results were undeniable. The final area was indeed larger than the sum of the initial two, perfectly confirming Hawking's theorem. It's an emotional moment for physics. Kip Thorne, one of the Nobel laureates for LIGO, mentioned that Hawking himself called him right after the first detection in 2015, eager to know if his theorem could be tested. He would have been thrilled to see this confirmation. It's a beautiful testament to how theoretical physics, sometimes seen as purely abstract, can be proven by observation decades later. What does this all mean for the future? Well, as Professor Emanuele Berti from Johns Hopkins University puts it, the LIGO team has spent a decade improving their hearing aids for the universe, and now we can test principles of gravity we couldn't even dream of testing 10 years ago. We are entering a new era of gravitational wave astronomy. Experts agree this event is a milestone. It proves the success of the ongoing upgrades to our detectors and lays the groundwork for even more precise discoveries. Future observations promise to test our understanding of gravity, space-time, and the very nature of reality in ways we're only just beginning to imagine. We're not just looking at the stars anymore. We're listening to the symphony of the cosmos itself. This is why science is so exciting. A prediction made a century ago by Einstein, refined by Hawking 50 years ago, has now been heard, measured, and confirmed a billion light years away. What an incredible time to be alive and looking up at the sky. Thanks so much for joining me on this cosmic journey today. If you found this as fascinating as I did, please hit that like button and don't forget to subscribe and ring the bell so you won't miss our next deep dive into the wonders of the universe. See you in the next video. Hey everyone, welcome back to the channel. Have you ever looked up at the night sky and wondered what's still out there waiting to be found? For over 100 years, astronomers have been captivated by the idea of a hidden planet in our own solar system. And now a new study is adding fuel to that fire, suggesting a brand new candidate they've nicknamed Planet Y. So what's the story? Well, way out past Neptune, there's a huge ring of icy bodies called the Kuiper Belt. Imagine it like a cosmic debris field left over from the formation of our solar system. Astronomers notice something weird about the orbits of some of the most distant objects in this belt. They're tilted. Something big, something with gravity has to be pulling on them, disturbing their paths. The lead author of this new study, Amir Siraj from Princeton University, puts it this way. One explanation is the presence of an unseen planet, probably smaller than the Earth and probably bigger than Mercury, orbiting in the deep outer solar system. Now, they haven't actually seen this planet. This isn't a discovery in that sense. What they've discovered is a puzzle, and Planet Y is the most likely solution. This isn't the first time we've heard about a mysterious ninth planet. You might remember the buzz around Planet 9, a much larger, more distant world proposed a few years ago. The search for these hidden worlds has a long and dramatic history. It all started back in the 1800s after Neptune was discovered. Astronomers like the famous Percival Lowell noticed oddities in the orbits of Neptune and Uranus and theorized about a Planet X that was causing them. For a while, everyone thought Pluto, discovered in 1930, was this Planet X. But it turned out Pluto was way too small to have that kind of gravitational muscle. The mystery was eventually solved when the Voyager 2 probe gave us more accurate data on Neptune's mass. But the hunt was reignited in 2005 with the discovery of Eris, another icy body in the Kuiper Belt, which famously led to Pluto's demotion to a dwarf planet. This is what makes the Kuiper Belt so exciting. It's so dark and far away that it's incredibly difficult to observe. We're basically trying to solve a cosmic mystery with just a handful of clues. But that's all about to change. So, how did the team behind Planet Y even come up with this idea? Siraj and his colleagues were looking at the overall shape of the Kuiper Belt. You know how all the planets in our solar system orbit on roughly the same flat plane, like grooves on a vinyl record? The theory was that the Kuiper Belt should be pretty flat too, parallel to that record. But what they found was a shock. Beyond a certain distance, about 80 times farther from the sun than we are, the whole thing suddenly appears to be tilted by about 15 degrees. It's like the edge of a plate being bent upwards. They ran simulations to see what could cause this. Could it be a star that flew by billions of years ago? No, the warp would have smoothed out by now. Could it be left over from the solar system's formation? Unlikely. The only thing that consistently worked in their models was a planet. Based on their simulations, Planet Y is likely somewhere between the mass of Mercury and Earth. It would be orbiting about 100 to 200 times the Earth-Sun distance, and its orbit would be tilted by at least 10 degrees relative to the other planets. Interestingly, this doesn't rule out the older Planet 9 theory. Siraj says it's a heated debate, but it's possible they could both be out there. We could have a Planet 9 and a Planet Y. How wild would that be? Now we have to be clear. The evidence for Planet Y is based on the orbits of about 50 objects. That's a pretty small sample size. The statistical significance is strong, around 96 to 98%. But it's not definitive, it's tantalizing, but it's not a slam dunk. So how will we ever know for sure? Get ready for the game changer, the Vera C. Rubin Observatory. This brand new, incredibly powerful telescope is located Palabra Chave on a mountaintop in Chile and houses the world's largest digital camera. Starting this fall, it will begin a 10-year survey, imaging the entire visible sky every 3 nights. Siraj calls it a movie of the universe. This survey is perfectly designed to take a census of our outer solar system. It will discover thousands of new Kuiper Belt objects, giving us a much clearer picture of its structure. If Planet Y is real and within the telescope's view, the Rubin Observatory will be able to spot it directly. Siraj believes we could have a definitive answer within the first 2 to 3 years of the survey. Other experts in the field are cautiously optimistic. They praise the study's careful analysis, but agree that we need more data. Samantha Lawler, an astronomy professor, thinks there's promising evidence for a smaller body warping orbits, even if she's skeptical about the larger Planet 9. Patrick Lee Kafka, a planetary scientist, says this new study adds weight to the hypothesis of a hidden planet and highlights how crucial these new surveys will be. Ultimately, finding these distant objects isn't just about adding another planet to our solar system's roster. It's about unlocking the secrets of our own cosmic history. These distant, icy worlds are like fossils, holding the key to understanding how our entire solar system formed and evolved billions of years ago. We are truly living in an amazing time for discovery, on the verge of potentially redrawing the map of our own cosmic backyard. What do you think? Is Planet Y out there? Let me know your thoughts in the comments below. It's such an exciting time in astronomy, and we'll be keeping a close eye on the updates from the Rubin Observatory. Thanks so much for watching. If you enjoyed this journey to the edge of our solar system, please hit that like button and subscribe to the channel so you don't miss our next deep dive into the cosmos. See you in the next video.